go to STEM Schoology and to the Unit 1 folder, and then look for Unit 1 Part 2 and go to that folder. Scroll to the bottom and find Unit 1 Part 2 Build a Molecule Activity Sheet.pdf. Click on it. At the top of the screen, look for the vertical arrow that will fit your document to the height. Then click the 4-way directional arrow to make it full screen and take a screenshot of the first page. You can crop and save that screenshot to photos. Then scroll and take a screenshot of the second page and do the same thing. Go to Freeform, open up a new canvas, and insert images that you just took. And then you can enlarge them and place them side by side. And it would probably also be a good idea to lock them in place. Go back to the Unit 1 Part 2 folder. And at the bottom of the Unit 1 Part 2 folder, you'll see below the document we just opened a link called Build a Molecule link. You can open that up and click on Single. Now, before we jump into that, I want to show you a few things. Remember from the previous week, atoms. Atoms are the most basic building blocks of the universe, and they make up everything. And they're comprised of a proton, which is positive, a neutron, which has no charge, and electron, which has a negative charge. Now, the numbers of protons, neutrons, and electrons varies depending on the type of atom. Here we're looking at a hydrogen atom, so we only have one proton. And the protons are going to be what tell the difference between the different types of atoms. They differentiate them. So let me pull back and show you a website really quick. Here I have the periodic table of elements, and this is a list of all the different types of atoms. We call different types of atoms elements. Here's a hydrogen atom that we just looked at. If you look at the periodic table entry card, in the top corner, you'll see a 1. That means there's one proton. And in the diagram of an atom, you can see the red proton. Hydrogen is a gas. Now let's look at another type of atom. This is the second entry. It's helium. Helium is also a gas, but you'll see that it has 2 protons because the atomic number is 2. And if you look at the diagram, you can see 2 red protons. And this is how all the different atoms are organized. If I were to pull up gold, you could see that there are 79 protons in a gold atom. And this type of atom, this element, is very different from hydrogen and helium because it's a solid. It's a metal. It has a luster, so that means it has a shine, and we can shape it into different things. So the numbers of protons make different kinds of atoms. Most of the things in our universe are made from the first few types of atoms, such as hydrogen, helium, lithium, beryllium, boron, carbon, so on and so forth. But atoms go together to make up everything around us. We're going to look at how they go together today. So let me show you one other thing that you're going to need to keep in mind here. Before you see a diagram, or I should say a drawing of a molecule. This molecule is a water molecule. That's the molecule name, water. And the drawing that I have here shows that it has 3 types of atoms. We have an oxygen atom and 2 hydrogen atoms. We have a chemical formula for this, which is different from the molecule name, that shows that it has 2 types of atoms. There are hydrogen atoms, that's what the H stands for, and oxygen atoms, that's what the O stands for. The 2 beside the hydrogen is called a subscript. I'll show you that over here. Subscript comes from another language. It's 2 word parts. Sub means under, like in subway that goes under the ground, or a submarine that goes under the water. And script just means to write, as in like scripture or a prescription like your doctor would write. So we write it under. You can see how the 2 is slightly below the H and the O. The 2 indicates the number of atoms of the type of atom it comes after. So in this instance, it means that there's 2 hydrogen atoms in a water molecule. And so we have 2 hydrogen atoms. Since O doesn't have any subscript, it's assumed that it's a 1. So there are 3 total atoms in a water molecule. And again, here's the illustration of that right here. So this chemical formula tells us what kinds of atoms and how many there are in forming this particular type of molecule. So when we put atoms together, we make a molecule. So we're going to build a molecule right now. Go back to the website, and I'll show you a couple things. On the right side of the screen, there are collection boxes. In the top right, it says H2O, water. So we have the molecule name, water, and we have H2O, which is the chemical formula. We're going to use the chemical formula to actually make a molecule by combining those atoms together. So we have H2 in the chemical formula at the start. That tells us, according to the subscript, that there are 2 hydrogen atoms, which I will pull out now. And then we have 1 oxygen. So I'll pull that out, and we can put them together. The oxygen needs to go between the 2 hydrogens, and you saw the blue arrow pointing to the container flashing. Now we can click on the 3D to see what this molecule looks like, and this version to see the bonds between them. And we can drag that over to the container box. If we were to need to refill the containers down below, I could click on the refill arrow on the left side of the screen, and they would be refilled. Also, there are gray bars on either side of the white rectangle at the bottom of the screen with a black arrow in them that we can click to get to different types of atoms in different containers. So I'm going to go to the second one, because the second thing we need in the second container below H2O, water, is O2, molecular oxygen. So according to the chemical formula, O is what we'll need, and we need 2 of them because the subscript is beside it. So we're going to put it together and make O2. And I'm going to drag that into the molecular oxygen box. You can be doing this too. See if you can make H2, CO2, and N2, and you can pause the video while you do that. Hopefully, you were able to make H2 like this by putting 2 hydrogens together, and go to the next rectangle and make CO2. And then hopefully you're able to make molecular nitrogen. So we would have filled the whole thing in. Now we're going to go back to freeform, and we're going to fill in our activity sheet. And I should have read these goals before, but I'll read them now. Our learning goals are to describe the difference between a molecule name and a chemical formula, distinguish between the coefficient and the subscript in a chemical formula, and use pictorial representations of molecules to generate chemical formulas. We'll start by answering the first question of the first screen, first single. Make a molecule. How do you know you made a molecule? We know we made a molecule because we put at least 2 atoms together. Whenever you have a molecule, as in the case of the water that we made earlier, we're going to take different types of atoms, like in this case, we had 2 hydrogens and 1 oxygen, and we're putting them together. Now, this one has 3, but if you remember it carefully, we didn't always have 3. We had some instances where we had just 2, as in molecular oxygen, molecular hydrogen, and molecular nitrogen. So 2 is enough. So to go back to what we just said, you need to put at least 2 atoms together. So we're going to write that in our notes here, and you'll put it right on this line, that sentence that we just looked at. The next thing we're going to do is write the name of some molecules that we made. So some molecules that we made that we can write the names of are water and carbon dioxide. Yes, we had molecular oxygen, molecular nitrogen, and molecular hydrogen, but we're just going to write 2. So we'll write carbon dioxide. So you can write that in now on the lines right here. And the box down below says molecule name, drawing, and chemical formula. We're going to show the difference between the molecule name and the chemical formula. So to do that, I have it created for you here. And you can just pause the video and copy mine as you've done for the other boxes. Feel free to go back if you didn't fill them in and come back to this part of the video. But you're going to write for the first one, water, do a drawing of a water molecule, and then write the chemical formula H2O. The molecule name of the second one is carbon dioxide. Here's the drawing, and here's the chemical formula. And the third is molecular oxygen. Here's the drawing, and here's the chemical formula. Pause the video so you can include that right now. We're going to shift over to the second half of the worksheet now, the backside. We're going to be looking at the second screen, multiple. And we're going to make many. Fill all the collection boxes and then complete the questions for each goal. So here we have the goal of creating 4H2. We need to draw it. We need to tell what the big 4 means in 4H2 and what the little 2 means in 4H2. So to do that, I want to show you really quick another thing on the board here. We talked about subscripts, the little 2's, but now we need to add another element called the coefficient. So you can remember that this is the chemical formula for water, H2O. And you can also take a number and put it in front called a coefficient to tell us how many of these molecules we're going to have. Now, I'll show you how we use this. You almost ignore this number to start just so you can make the molecule, but then this tells us how many we need to make. So let's navigate back over to the Build a Molecule website and look very carefully at the bottom. There's a house at the bottom, then there's single, and then there's multiple. Click multiple. On the right this time, we have collection boxes for 2 CO2, 2 O2, 4H2, and 2 NH3. Since we were just looking at 4H2, go down to the rectangle and click the arrow in the gray bar twice so that you have a container full of hydrogens. And we're going to make some H2s. You can see in the goal for the third container, it says 4H2. Ignore the 4 and let's just make H2s. I'm going to make one. Again, this is what it looks like. And I'm going to drag it over to the H2 box. Now, if you look carefully under the 4H2, it says 1H2 because I only have one of those. Let's add another one. Now I have 2 H2s. So you can see that coefficient is showing us how many molecular hydrogen molecules we have. I'm going to add a third one. Now we have 3 H2s in there, and I'll add a fourth one. Now I have 4 H2s. I've satisfied the goal, and I have a coefficient of 4, so I needed 4 molecular hydrogen molecules. Let's do 2 O2 right above, in the container right above. So I need O2. There's 1, but I haven't satisfied my goal. I need a coefficient of 2, so I'm going to make another one. We can do it for nitrogen, and I'm going to refill my container here. At the bottom, goal of 2 NH3. So I'm going to ignore the number at the beginning and just look at NH3. N for nitrogen and 3 hydrogens because it's H3. That tells me how many atoms. So I've got this. This is called ammonia. Here's what it looks like. And I'm going to drag that into the container. But I need 2 of those, so I'm going to make a second one. And I'm going to drag that into the container. Now I've satisfied that. Let's go back and make 2 CO2s now. So I'm going to make a CO2 because I'm going to ignore the number at the beginning. I've got 1 of those. Let's make a second one. Now I've got 2 CO2s. So that coefficient that we just looked at a moment ago, the goal of the coefficient is just to tell us how many molecules and the number of molecules. So let's go back to the worksheet here. And in the worksheet, you'll see that our first goal is to draw 4H2. So if I show you when drawing on the board here, you'll see at the top, I have 4 H2s. So you can draw that right here, right now, and pause the video if you need to. The next question says, what does the big 4 in 4H2 mean? And what it's actually telling us, if you recall, is how many molecules of H2 we need. So you can just write how many molecules. The little 2 in 4H2, by contrast, is not telling us the number of molecules, but if you'll recall, the subscript tells us the number of atoms. So it tells us, hey, we need 2 hydrogen atoms. So you can write how many atoms for that box. And when you're done writing that, I encourage you to use what we looked at just a moment ago, to use the game to fill out the remaining 2 boxes down below, the 2 CO2 and the goal for 2 O2. And hopefully this has given you a better understanding that, and I'll pull this up again, a molecule is just a couple of different atoms together, such as 2 hydrogens and 1 oxygen, as in the case of water or a water molecule. So a molecule is just when we put atoms together to make something from them.